Hi, today we're going to talk about real-time analytics with open source technologies like Apache Kafka on Azure HDInsight. I'm Raghav Mohan, Program Manager overseeing open source streaming, which includes Kafka, Storm, and Spark streaming on Azure. Enterprises today have an increasing need to build real-time pipelines for low-latency, high-throughput scenarios encompassing IoT, clickstream analytics, financial analytics, and so on. Due to their large scale, developer ecosystems, and flexible architectures with on-prem or other clouds, enterprises want to leverage open source technologies such as Kafka and Spark for their use cases. Before we dive into how to build streaming pipelines with open source technologies, let's talk about why enterprises are building these real-time pipelines and the real-life scenarios that they power. One such example is GE Healthcare, who's using their big data analytics to fuel their digital health revolution. They have clients installed on various hospitals, clinics, and patient endpoints. And from this, they're ingesting and processing very large volumes of data via Apache Kafka and Apache Spark on Azure HDInsight. This real-time pipeline helps clinics reduce costs, it increases efficiency, and allows for real-time machine learning to be leveraged for today's patients. This is just the beginning of the new wave of healthcare being powered by big data, AI, and machine learning on Azure. A key IoT scenario where Azure has been working very closely with is Toyota's connected car, where we're processing telemetry from all new Priuses and Camrys, and this translates to around a million events per second being processed on Azure. Toyota is ingesting this data to power scenarios for their end customers that encompass pay-per-mile insurance, where the end customer's costs can drastically be reduced because you are only paying for what you use versus a fixed month amount. Another scenario for the connected car is the safer and predictive telematics, where we can marry the static profile data with behavior driving patterns of a particular driver, and then take the real-time data from the sensors of the car to give some personalized recommendations to say that user X should take their car faster than user Y to the shop for servicing. For ingesting data at Toyota scale, which is again millions of events per second, they need to use technologies like Kafka to process this data at scale. They've deployed out Kafka and Spark and Storm in various different regions on Azure today, and this is being processed today to power their connected car scenario. Now that we've talked about the scenarios that are powered by open source streaming, let's talk about how to build these on Azure. A typical streaming architecture on Azure looks something like this, where we start with events that stream in at a very, very high rate. These can be either your clickstream events or your IoT sensors or data coming in from other sources. We need some technology that's going to be able to ingest these events at a very, very high rate. And Apache Kafka has become the industry de facto for open source ingestion because it can handle low latency, high throughput workloads in a very elegant form. From there, we're going to use technologies like Apache Spark or Apache Storm to process these events and do some real-time computations, some aggregations, even machine learning, and then pipe this data out to either long-term storage, or we're going to pipe it out to another real-time application that's going to consume this data and then do something more intelligent with it. Or we can pipe the data out to real-time dashboards for alerting and monitoring. While using these open source technologies to power the enterprise scenario sounds very attractive, there are key challenges with using the open source technologies as is. Getting up and running with these open source technologies is hard. Sizing the machines, installing the bits, and configuring them seems to be a challenge. The enterprises need to have the in-house talent that knows these technologies in and out to have the expertise to tune them to the correct performance metrics. Next, they need highly trained site reliability engineers and live site experts to ensure that there is zero downtime for the pipelines. This matters especially for the streaming scenario, as every second that the pipeline is down, they're actually losing data and the data is not being ingested. Next, there is no single authority for implementing security and compliance for these open source workloads, which is a key requirement for most of the enterprise use cases. Finally, there's not a one-size-fits-all for these open source technologies and their architectures. Each enterprise has a different requirement, and tailoring them to their needs requires some additional work. That is where HDInsight helps. HDInsight is a fully managed open source analytics service on Azure, which provides a 99.9% SLA on key big data workloads. It is 100% open source and built on the Hortonworks data platform, and we can deploy out clusters within minutes and scale them up and down depending upon the big data workload. This drastically reduces costs as you only pay for what you use. We have key features for security and compliance such as Azure Active Directory and Apache Ranger support, and compliance features for HIPAA, SOC, PCI, and so forth. HDInsight had workloads for Hadoop, Hive, HBase, Storm, Spark, and R Server. And when we surveyed streaming architectures on HDInsight, the key feedback that we got was that there is no Kafka as a managed service, and ensuring that the Kafka bits are up and running has a high cost of ownership and is in general hard for the enterprise use case. Because of this, HDInsight added Kafka as a managed service to the HDInsight family, and today we're announcing the general availability of this service. Kafka on HDInsight is a managed service with a 99.9% SLA. This is not just the SLA on the underlying VM instances, but on the end-to-end service. We ensure that your brokers are up and running for that amount of time. We've also integrated natively with Azure Managed Disks, which allows for an exponentially increased scale as these workloads are scaled out to either Toyota or Adobe's case, but it also allows for an exponential reduction in cost because the cost of adding an additional disk is a fraction of the cost of another node. When we also have implemented features for rack awareness for Azure environments, because when a Kafka implemented rack awareness, it was implemented with a single dimensional view of a rack, whereas on Azure, the rack is a two-dimensional view. So HDInsight has done a lot of work to ensure that our customers can take advantage of this rack awareness feature. We also integrated natively with Azure Monitoring, which we will see in a minute, where we expose out all the metrics from the disks to the JMX metrics of Kafka so that we can predictively monitor and also maintain our clusters. Finally, we deploy these Kafka clusters within virtual networks, and this virtual network provides a security boundary. We can peer virtual networks from one virtual network to the other, or we can connect from our on-prem devices to these virtual networks via VPN. So with that, let's jump into a demo. For this demo, first we're going to deploy a Kafka and Spark cluster in the same virtual network on Azure HDInsight. Next, we're going to simulate a real-life taxi cab pickup scenario where data from rides is being streamed in real time. In this example, there's a process running on the Spark cluster that is simulating the data for the pickup scenario, and it's publishing the events to Kafka. The same Spark cluster will then consume the events from Kafka and then display them into a real-time tumbling window in a SQL table. So when we go to the Azure HDInsight portal, we'll see that we can add the cluster name, our administration for the cluster login and password, but we can also choose the cluster type. If we drop down here, we'll see that we have the different workloads that are listed with Kafka. If we choose the Kafka workload, then we can choose the Kafka version and hit select. We can go ahead and enter in all the other additional information needed, including the storage account details and the applications that we want installed in addition to Kafka, such as stream sets. Next, here we can easily choose the number of worker nodes and the disks per worker node. In this case, we're going to add 8 terabytes of storage to the Kafka cluster because we have 4 disks with 2 terabytes per disk. But this can go up to 16 terabytes per node, up to 48 nodes per cluster. Once we are done with all the advanced settings for the cluster, such as the virtual networks, this cluster will get deployed within around 10 to 12 minutes. While the portal offers a great, rich experience for visual experience for deploying out these clusters, if we want to deploy these clusters out with a quick fashion, especially for large-scale pipelines such as Kafka and Spark, we can go ahead and we can use our search engine to look for docs for HDInsight, Kafka, and Spark. Once we do that, we'll see that we have actually created the documents for Kafka with Spark streaming for both types of Spark streaming and Kafka Storm, where these clusters are deployed out within the same virtual network for Kafka and Spark. All we have to do is click on this blue Deploy to Azure button, which will take us to a ARM template, which is a JSON document where we have pre-populated all of the template parameters for a Kafka cluster, Spark cluster, and all the virtual network. So here we can see that we have the Kafka cluster, the version, and the Spark cluster. And you can choose the number of VMs and disks we want, but you don't have to because we have made it very easy. All you have to do is provide the base cluster name and the cluster login password, and this will create all the resource groups, the storage accounts, the virtual networks, and deploy the clusters out within 10 to 12 minutes. Once this template has finished deploying, we will see something like this, where a resource group is deployed, and we have the Kafka cluster, the Spark cluster, the storage account, and the virtual network all deployed within the same Azure Virtual Network. We have rich templates for not only Kafka and Spark within the virtual network, but also how to connect from your on-prem devices via VPN through a public gateway as well. Once we have this deployed, if we go into the Spark cluster, we'll see that we have the Spark cluster dashboard, where we have everything with the administration of the cluster. If we want to scale the cluster up, we can scale it. If we wanted the SSH into the cluster, we can. But if you click on the cluster dashboard, it will take us to the Jupyter notebooks that are installed within this Spark cluster. If we keep following this documentation article, we will see at the end that it will take us to a GitHub page where we have the Spark notebooks uploaded that we will be using today. There are two Spark notebooks, one that is going to stream to Kafka and one that is going to read from Kafka. So let's start with the one that is going to stream to Kafka. I'm going to run all the cells, and in this, we're going to first create the Kafka topic, and then we're going to have the process working on the Spark cluster that's going to simulate the taxi cab data. As it is doing this, we're going to SSH into the Kafka cluster to ensure that our data is being streamed. So this is SSH'd into the Kafka cluster, and if I just stream if I just describe the topic, it will give me the events that are being streamed to that topic. And as we can see, in real time, we're getting the taxi cab events where we have data from the drop-off time, the pickup time, what the surcharge was, the payment type, and so on. So as this data is being streamed into Kafka, now let's go ahead and read from it. So in this Spark notebook that is pre-populated, we have all the code where we're going to read from the Kafka topic, and we are going to set our batch interval to 6 seconds. And every 6 seconds, we're going to say that, for the last 6 seconds, what was select from the taxi cab table the events that are being streamed in. So as we can see, the Spark application was started, and now we have all the events being streamed into this temporary SQL table. And we're also piping the data out to the Jupyter notebook. But since this is a real-time SQL table and these events are still being streamed in real time, every time that I run this cell, we should see different results on this table, because it's looking back from in the last 6 seconds, what were the taxi cab trips that were taken. I can keep doing this, and we'll see that since it's a tumbling streaming window, we can do the real-time SQL analysis, and I can do something even more powerful to say, what was the average surcharge in the last 6 seconds, or what was the average wait time in the last 6 seconds, and do some powerful streaming queries here. So while we can do the streaming queries in the Jupyter notebook, if we go back to the Spark cluster, we will see that on the left-hand side where we have all the administration, we also have a tab for monitoring, and this is where we've integrated with the rich monitoring experience for the Azure HDInsight clusters. Here you can just hit enable, and this will enable the Azure monitoring on your Spark cluster or even Kafka cluster. And through your monitoring dashboard, so in this monitoring dashboard, we can have some rich queries that can drill down all the way up into a single Kafka broker or a single Spark worker node, or you can aggregate it per cluster. And here we were streaming data into the Kafka cluster, and we just stopped streaming, so that's why this drops. But not only can we monitor this through the operations management suite, we can click on alert, which will take us to the alerts page, where we can not only set an alert based on a threshold that we specify for this metric, but we can also choose who this alert gets sent to, and we can specify webhooks or runbooks to say that when this metric reaches this threshold, take this action. So we can imagine where we say, if a disk is 80% full, add more nodes to the cluster. And we can do this sort of predictive maintenance on this cluster through this really powerful and rich monitoring tool. With that, if we just go to the aka.ms/HDInsight Kafka homepage, we can see that we have all the latest updates for the Kafka and Spark clusters on HDInsight. But at the end, we have also added a learning path where we can either deploy Kafka on HDInsight with one click, we can configure the managed disk and scalability, but we can also deploy out the other pipelines, either Kafka with Spark or Kafka with Storm, Kafka with Spark on Azure HDInsight. You can also learn more about how to use the Azure monitoring and also how to connect from either on-prem or use Apache Mirror Maker for disaster recovery scenarios for mirroring from one HDInsight Kafka cluster to the other. So hopefully that gave you a good overview of how easy it is to get started with open source streaming, especially Kafka and Spark on Azure HDInsight. There are resources listed here where we can go and deploy either with Kafka with Storm, Kafka with Spark, or Kafka just by itself and learn more about Azure HDInsight. Get started today. Thank you.